Welcome to part 2, where I'll be teaching you how to do Canvas JavaScript. So, back again with my simple sample document and just my basic stuff in my script.js. So we'll be learning loops, input, and at the end we'll make a small mini game. So, first with loops. Now, in JavaScript, if you try to do a while-true loop, like in any other language, and let's do ctx.clearRect. By the way, ctx.clearRect is how we can erase the entire everything. It's how we clear the display. So 0, 0, 500, 500 will clear the entire thing. ctx.fillRect, and we'll do that at 0, 10, 10, 10. And we'll actually put in a variable here. So let's put in variable xchord. We'll set that to 0. And we'll also put xchord here, because if you can put variables as parameters. So now xchord plus plus, just that way we see something noticeable. And as you can see, it can't load because a while true loop doesn't exactly like while true loops. So I'm just gonna reopen that again. Or not. So we don't want this while true loop. And we can get rid of that variable. So what do we do instead? Well, we do something called setInterval. It takes a function and it gives how, and then you have to, so it takes a function and then the delay between each individual instance that function runs. So if you were to do 60 frames per second, by the way, it's in milliseconds, and 1,000 so 1,000 milliseconds equals 1 second. So for 60 frames per second, we do 1,000 divided by 60. But let's have this at something more like 10 FPS. So 60 divided by 10. No, 1,000 divided by 10. Let's do the same thing again. Var. Let's just do var x. ctx dot clearRect x 0, 10, 10. Wait, no, this is clearRect. Let's just change this back to fillRect. And we want to do a clearRect. 0, 0, 500, 500. And I would need to reopen this. Okay. And it's not crashing. And we can do x plus plus. And slowly but surely it's moving all the way along. Now, what would happen if we were to comment out clearRect? It would just look like one giant line, because it's not resetting itself. So that's why we want that at every single instance. So that's loop's done. Let's check that off. Now for input. For input, it's a little bit weird. You have to do dot on key down equals function, and we need to take an input of e. And we can't do like something like if e equals w. That won't work. So we have to, what we can use is some string dot from char code e dot key code, and that'll give out a actual string. So we'll do let res, because we just want it to be a temporary variable, set that equals that. And we'll do if res equals to w. So if res equals to w, we'll do, actually let's do res equals to space. Now you literally just press the character for space. If res equals space, then let's do x plus equals 10, and we'll get rid of this. So if I press space, it moves across. We can also, so now that we got loops and input, oh wait, no, we're not done with input. So let's do something like alert res. Now spacebar will appear as a space. Hitting the enter key actually appears as a new line. Hitting 0 on numpad gives this. It's really weird because you can't just press the key, because something like the arrow keys give things like this. The plus key on numpad gives this. Delete gives this. End, insert, home, page up, page down. Now, arrow keys and the arrows on numpad are treated the same. Because I think they're treated the same on operating systems as well. 5 is actually that giant up arrow. It's interesting. So enough with that, because obviously things have strange things, and the F keys have even stranger. So F1 triggers something. F1 triggers something in Chrome, so F3 does that in Chrome. F4, F5, F6, F7, F8, F9, F10. Now, alright, now that we got that out of the way, let's make a little mini game. So, the mini game will be 2 characters, a player and an enemy, and the enemy tries to move towards the player at a rate that is slower than what the player can move. Now, one thing to note for input, this is very important. Open a new tab and hold down a key. That's the rate in which the computer will take the input. It's like one giant spurt and then a constant continuous. And so if we want to have, normally I have a little object which I call keys, and I set the A key to false, W key to false, S key to false, and G key to false. That way we can do if res equals to W, then keys.w equals true. And if res is equal to A, keys.a equals to true. If res is equal to S, keys.s equals to true, and for this last one, let's just copy paste because I am a dum-dum and didn't do that. So D and D. Now there's no x coordinate, so ccx.clearrect, and we'll also have a var player object, and we'll set this to x 0, y 0, and we'll have an enemy object, and we'll set their x to 490 because we want them to be at the bottom. We want them to be at this corner. But if we set it to 500, 500, it will appear outside this. With a width of 10 and a height of 10, we want 490, 490. So simple subtraction right there. X is 490, Y is 490. And now, if keys.w, so if keys.w, then player.y minus equals 10. Then keys.s, player.y plus equals 10. and keys dot A and keys dot D. We want player dot X. And those are the correct ones for plus and minus. Don't want that S there, that'll cause us problems. Now we haven't had it drawing yet, so let's do that. ctx dot fill style equals black for our character. ctx dot fill rect player dot x player dot y 10 10. ctx dot fill style equals red. ctx dot fill rect enemy dot x enemy dot y 10 10. Now what you might see is that as you begin to press one, it'll just keep on going. And also we don't have to keep that 10 FPS. We can put it up to 60 and then bump these down to something more like 2.5. Because hey, as we remember, we can put floats into these. Now you might notice that eventually, as I press all the characters, it begins to do that. We don't want that. We want it so that way, because we're only setting it to true, but we're not setting it back to false. So in order to do that, we copy this entire statement, and instead do on key up. So it's not when you press the key down, but it's when you pull the key up. And we'll set all these trues to falses. I had a selection. True, replace it with false. Did all of them. Why did it do all of them? Whatever. This is okay. So we replaced all the trues with falses and all the falses that I just reset back to trues. Now, when you stop pressing the key, it stops going. Now to get our enemy logic. Oh, we also don't want our player going outside of boundaries. So let's have if we don't want that in there, we want that in our loop. So if player.x is greater than 490, then player.x equals 490. And same for player.y. And we don't want it going back the other way. So grab this, put these two less than signs. So if it is less than 0, we want to set it to 0. You could have looping by putting it the other way around, but now it's just hard edges. And nothing happens when I collide with this. So now we want to do enemy logic. So if player.x is greater than enemy.x, enemy.x plus plus. Let's just do it by whole numbers. So now enemy of x is less than enemy.y, enemy.x minus minus, player.y is greater than enemy.y, enemy.y plus plus. Same logic for y. Now it's going to come at us. But hey, one thing you might notice is that if it collides with us, absolutely nothing happens. So for this, I'm just literally going to kind of cheat for this, and Mozilla 2D collision. Trust me, this I've used too many times. And let's paste this in. So if we'll have rect1 be player. Actually, I think we can use this now. So player, no, we want rect1. Replace this with player, and replace all. Rect2, replace this with enemy, and do all. And for all the widths, I want them to be 10. All the widths and heights are going to be 10. So 10. Now, we didn't put anything into our collision script. So, for this, we want to do, we want everything to reset. So we'll just redeclare this. And get rid of our, and that space. So now if we reload and let it get us, everything resets. Now we have a fully functional game in JavaScript. If you like this video, you know what to do. Hit that like button, and if you want more content, please subscribe. Thank you.